So this is the next in my sequence of sort of mathematical sort of katas.
What's a kata?
Oh, a kata! Why didn't you tell us what a kata is?
It's a chance to where you practice something that you're doing lots of times over and over so that you get better at it. And in the context of the Ruby group, we do test-driven development katas, which means you write your tests first, then you write your code, then you write your tests, so on. You let your tests drive your code.
Great. And of 3 would be equal to 4. And we would expect that rotation of 5 would wrap around back to 1. So let's see if we can get all of those to pass at once. So what we need to do is we need to...
See if it fails.
Hmm?
Should see if it fails.
Oh, yes. Very good. Oops, something happened. Didn't happen. There we go. We don't have the bracket operator defined. So let's define the bracket operator. So all we need to do here, and this is the beauty of having used a lambda as the data in our class, is all that we have to do is do f.call x. And we passed. So the next thing is that we want to be able to support composition of permutations. In other words, we want to be able to apply one permutation and then another permutation on top of it and get the combined result, which will again be a permutation. And although Ruby doesn't really have a great operator to use to overload for composition, a lot of people use asterisk, even though it has some disadvantages. So let's use the asterisk operator. So what we want to do here is we're going to expect that if we take rotation and compose rotation with itself, and then convert it to an array, we're going to expect that to equal, it's actually going to rotate once, then it's going to rotate again. So before we got 2, 3, 4, 5, 1, now we're going to get 3, 4, 5, 1, 2. We should. So let's see if we do. Oh, a failure. No method star is defined. So I'm going to go over here, and I'm going to define star as an alias for compose. And what happens here? Undefined method compose. Now the reason that I did that is that I think the choice of the symbol to use for these overloaded operators is sometimes problematic. So I prefer to implement in a case like this a compose method and then separately determine what symbol I want to use for it with the operator syntax. So now I'm going to define compose, and I'm going to compose F with G, okay? Which means that we're going to apply G first and then F. So what we're going to need to do here is we're actually going to need to define another lambda And this lambda is is just going to apply f to, oops, to g dot f applied to x itself. Okay? And then we actually need to create a permutation with this. So we're going to have this return p dot new using this lambda that we've just constructed, and see if that does the trick. Does that look correct?
No,
I'm not sure the syntax of G dot F
Compose
is.
would be.
Why do you have F twice? Is that
Because f is the member. F is actually the member of G. G is a permutation. So
oh yeah.
you see, so it's actually G dot F is the lambda.
Yeah.
So F is applied to G dot F is applied to X.
The problem is you're trying to call a lambda using the bracket operator.
But it works.
Which you can do.
Oh, you can.
You can
Yes.
do,
Yeah,
that
whoa,
works.
okay, that
Yes.
totally works.
So, yay.
Couldn't you just use the bracket operator on G since
Yeah.
you've defined
That's
it?
what I thought.
Oh yeah.
Just get rid of
Yeah.
that.
How is that going to work?
Because you've defined it.
Brackets on P.
You defined it on line 22, so now
And
you
you
use
said
it on
G
line
is a key.
27.
I did. That's great.
Yeah.
And now it makes much more sense.
Now it looks much better. Thank you for that improvement. Beautiful.
Thank you.
Okay, now it actually looks
knew it
like
was wrong.
composition. All right, now
It's F of G. I was like, what
the next thing is that we want to be able to create a permutation from a cycle. So, so what we want to do is to be able to expect that we can do P from cycle and then pass this a cycle, like what was the example that we have up here? Is 1 goes to 5 goes to 2 is the cycle. And we expect this to be a permutation that is equal to, let's see, 1 goes to 5, and then 2 goes to 1. 3 is going to go to itself. 4 is going to go to itself. And then 5 goes to 2. So that's what we would expect it to be.
You need to call 2A.
And that's correct. Dot 2A. That looks good. And of course, we haven't created a from cycle. So now here is a case where, we had a couple of ways that we could have chosen to implement this. When we have already a constructor for a permutation. And one style of dealing with this would be to put some type checking code in the constructor, see what arguments are passed into the constructor, and if initialize, that f argument to initialize is in fact a function treated one way, if it's an array, treat it as a cycle and do something different. In general, I don't like that style of code. If you look at Rails, you'll find that there's an awful lot of code like that. In a case like this, I think that it's a more attractive practice to simply create a factory method as a class method, which is obviously what I assumed I'm doing at the point where I wrote capital P from cycle instead of p.new. So we're going to define self dot from cycle C.
Type of self,
Hmm?
Missing an L.
missing the L in self.
Line 14.
Oh, very good. Whoops, that's not going to help. All right, and we're still not passing, but at least closer. So what are we going to do about this? Well, we're going to have to create a new, we're going to have to call the actual constructor of the class, p.new, and we're going to have to call that with a lambda. And so in this case, the lambda may be a little bit more complicated, so I'm going to write it like this, with on a couple of lines. I'm going to put do and end here so that I don't have to try to get it all in one line. And basically what we're going to do here, it's trying to be very helpful here. You don't need that. What we're going to do here is we're going to see whether X is mapped by the cycle, and if not, we're going to map it according to the identity. So let's see if our variable X is in the cycle. So I'm going to take an index here, I'm going to define it as J. I'm going to take C as the array, and I'm going to take index of X, okay? So that's either going to return the index of X if it's in the array, or it's going to return nil. So then what I can return here is, depending upon whether or not J is true, if it's nil, it's false. Then we're going to take the next element in the index.
Just one second.
So all we need to do here is to take C of J plus 1, and then we need to modulo that by C dot size so that it wraps around. And then so that's what we want if it's in the cycle, and if it's not in the cycle, we just want to return X because we just want the identity defined outside the cycle. So let's see if that does the trick for us. And it does. So I'm actually out of time. It's too bad that we didn't get to the point of actually doing the cycle decomposition the other way, which is kind of fun. But at least this gives you an idea of how you go about using test-driven development, not just to implement some fancy algorithm, but actually to help you build out a class library.